In this lesson, we're going to look at problem solving with quadratics. So the steps that you should consider when doing a word problem are: draw a diagram if necessary, write an equation using x for the unknown, solve the equation, check the solutions to see if they are appropriate to the original problem. In other words, for instance, if one of your values of x is negative and x is a length, then the negative one wouldn't be appropriate because a length should be positive. And answer the question in a sentence. That's always true. Like if a question is given in a sentence, like a word problem, answer it in a sentence. Okay, so let's look at question 1. It says, the product of two consecutive even numbers is 224. Find the numbers. Because it's important to define what x is. So we should let x be the first number. So then the next number would be, well, since they're even numbers like 2, 4, 6, 8, if the first one's 2, then you would need to add 2 to get to the next even number, which is 4. So the second even number would be x plus 2. Now, when we solve it, I'll explain why it's important to do that definition first. Okay, so it says the product, of course, product means multiply, of two consecutive even numbers. So the product of x and x plus 2, we could write that as x times x plus 2. And the product is 224, so that equals 224. And then the question says find the numbers. So I'm going to solve this equation. So first I need to expand the brackets. It becomes x squared plus 2x equals 224. Then I need to move the 224 over, so I'm minusing 224 to both sides. Cancels out here. And so I get x squared plus 2x minus 224 equals 0. So now, I need to solve that. I'm going to use PSF. So I have x here, now two numbers that multiply to 224. That could be, I think it's 14 times 16. Let's just check. You can do it on your calculator. 6 4s are 24, 6. Yep, that's it. So it's 16 and 14. But I need them to add up to a positive 2. So it must be positive 16 and negative 14. If you couldn't do that, you could always use quadratic formula. So here, my first solution is x equals negative 16 and x equals 14. Now, this is where it's handy to have the definition up here. If x is the first number, then x plus 2 is the second number. So by adding 2 to both of those numbers, you get the other number. But girls, have a think about, can negative 16 and 14 be an answer? Now if I read the question again, it says the product of two consecutive even numbers. That means they could be negative or positive. They didn't say they had to be positive. So if x equals negative 16, then x plus 2 would equal negative 14. So therefore, the numbers could be negative 16 and negative 14. Or, now let's look at our other solution. If x equals 14, x plus 2, which is the second number, is 16. So the other pair could be 14 and 16. Okay, so we've got two pairs, these two or these two. It's important that you make it clear what the pairs are. For instance, our two numbers couldn't be 14 and negative 14, so it's really important that you make sure you've paired up the right numbers. Okay, question 2. A rectangle has a width 5 centimeters shorter than its length. Okay, the second I see the word rectangle, I know I should draw a rectangle. And it says the width is 5 centimeters shorter than the length. Okay, so we want to find its width. So let's let the width be x. The width is always the shorter length. And therefore, the length will be x plus 5 because it's 5 centimeters longer than the width. Okay. And it says, so that's the 2 dimensions. And we've got them in terms of x. Now, I don't need to write out a definition here. I don't need to say let x equal this because the actual diagram defines x for me. Now, the other bit of information we've got is the area is 150. To find the area of a triangle, obviously you do the length times the width. So in other words, x times x plus 5 must equal 150. So I need to solve that equation now. So expand the brackets. Minus 150 to both sides. So it all equals 0, because remember, girls, you need to have your quadratic to equal 0 before you solve it. And we're going to solve that. Feel free to use quadratic formula or guess and check on your calculator to work out your 2 numbers. But they are positive 15 and negative 10. Hopefully you can see that because they add up to 5 and multiply to negative 150. So according to that, x equals negative 15 and x equals 10. But wait a minute, x is a length. It's the length of the width. Therefore, x has to be positive. So to show that you understand that, it's important that you write, but x must be positive. Or you could even say, but x is a length. Therefore, x is 10. Now, wait a minute. They asked for the width. So we should say, therefore, the width is 10. And what are my units? They're centimeters. Okay, so we've answered that question. Okay, so in this 3. Example, now I've actually realised I've made a mistake. To bend a 10 centimetre piece of 14 into perpendicular to 12 centimetres square with area of 14 centimetres. It says, all right, is it possible to bend a 10 centimetre? Let's think of a triangle with a right angle. So they said perpendicular sides of a triangle. So they're talking about that. And the 10 centimetre wire is just the perpendicular sides. Just this one and this one. So those 2 black sides there add up to 10. And they also the area of this triangle is 14 centimetres squared. Now, usually for a triangle, we have base and height. But they've said they must add up to 10 centimetres, the base and the height, or the perpendicular sides. So if the base plus the height is 10, then you could say either h equals 10 minus b or b equals 10 minus h. Either one. I might move the b over. Minus b from both sides. So h is 10 minus b. So what I want you to realize is now this vertical side can be also expressed as 10 minus b. Now, but we know the area. Now, the reason I wanted to do that, I'll just explain, is for quadratic equations like with x squared and things, you only have the one variable. So we want both unknowns to be in terms of the one variable. So that's why it's important to have the height in terms of b and this one in terms of b. And now we can solve for b. But before we get to that, we have to use the fact that the area of the triangle is 14 centimetres squared. How do you find the area of a triangle? The area equals half times base times height. So in this case, the area is a half times base times the height, which is 10 minus b. But I better put that in brackets. And in this case, the area is 14. So I make it equal to 14. And that's actually a quadratic equation that I can now solve. But let's simplify that a little bit. So on this side, we've got 14 equals. Now, girls, if you expand this part, I get 10b minus b squared. But then if I'm timesing all that by a half, I could put all of that over 2. Hopefully that makes sense to you. Now I'm going to times both sides by 2 to get rid of the fraction. And I get 2 times 14 is 28 equals 10b minus b squared. Now, as I've said before, it's a lot easier to solve a quadratic when the squared term is positive. At the moment, it's negative. So I'm going to move everything onto this side. In other words, I'm adding b squared to both sides. Cancel, cancel. So now my equation, I'm going to write over here. My equation becomes b squared plus 28 equals 10b. Now I'm going to minus 10b from both sides, and I get b squared minus 10b plus 28 equals 0. And so now we need to solve that. So we've got to try and solve this equation. I can't think of two numbers that will satisfy multiply to 28 and add up to negative 10. So let's use the quadratic formula. B equals now we've got the unknown as b, and also in the quadratic formula we use b, but that's the coefficient of the linear term. So negative b in this case is 10 plus or minus b squared, which is 100, minus 4 times a times c, which is 112, I'm pretty sure, over 2a, which is 2. So that becomes 10 plus or minus, look at this, negative 12 over 2. Oh, there's no solution all of a sudden because we have a negative under the square root. We also could have found that out by just doing the discriminant. But, now wait a minute, how can that be? Let's read the question again. Is it possible to bend a 10 centimeter piece of wire into the perpendicular sides of a triangle with area of 14 centimeters squared? The fact that there is no solution to this quadratic equation means it's not possible. So, therefore, we can write it's not possible. If you had found a solution for B, so that actually was a base and a height that would make this scenario possible, then the answer would be yes, it is possible. But in this case, we couldn't find, there was no solution to our problem, therefore it's not possible. Okay, last question. A floor is 20 meters in length. Floorboards are being laid vertically along the length of the floor. Okay, let me explain what I'm talking about here. Basically, if you've got a big floor, right, it's 20 meters in length this way, and floorboards are being laid this way vertically along it. So one here, one here, one here. So these are all floorboards. Okay, my beautiful drawing. Now, and they keep going all the way along. Okay, that's what's happening. If the boards had been 0.1 meters wider, 4 less boards would have been needed. What is the width of a floorboard? Okay, so our unknown is the width of these floorboards, which will let x happen. Okay, so at the moment, the way it is, the number of floorboards do fit perfectly into 20. But if the boards had been wider, 0.1 wider, they would have needed 4 less boards. So to make sense of this one, I'm going to introduce another variable as well. So basically, let's let x equal the width of a floorboard. The other thing I don't know is the number of floorboards currently when the width is x. So I'm going to let y be the number of floorboards. Floorboards for width x. So in other words, the number of floorboards needed to fill up 20 meters when the width is x. Okay, so x times y, for this floor that I've drawn here, x times y should equal 20. So, for instance, if I have 10 boards of a certain width, 10 times x should be 20. So the widths all need to add up to 20. Now, what if, though, I increase the width by 0.1? Now, what does that even mean? Basically, the new width would equal x plus 0.1. And for this new width, the number of floorboards is 4 less than the previous number of floorboards, which was y. So for the new width, it would be the new width, which is x plus 0.1 times y minus 4. So that's the new width times the new number of floorboards, which is 4 less than the original number of floorboards. And all of that would equal 20. Okay. So now, by using simultaneous equations, we can solve this. For instance, if I call this 1 and I call this 2, from 1, we can get y equals 20 on x by dividing both sides by x. Now I'm going to sub that into 2 and get x plus 0.1 times 20 on x minus 4 equals 20. So now I'm going to multiply that all out. And I get, okay, x times 20 on x. The x's cancel out and I'm just left with 20. X times negative 4 is negative 4x. Now 0.1 times 20 on x is like 1/10 times 20 on x, which actually becomes 2 on x. You can check that on your calculator by doing 0.1 times 20 if you like, which will just be 2, and then you've got the x on the bottom, so it's 2 on x. And then 0.1 times negative 4 is negative 0.4, which equals 20. So now I'm going to times everything by x because, first I'm going to simplify things. Now you might notice when I subtract 20 from both sides, these two will cancel out, which is very nice. And now also I don't really like decimals, so I might actually times every term by 10. So my equation becomes negative 40x plus 20 on x minus 4 equals 0. And now I'm going to times everything by x because I really don't like fractions being in my equation, and especially with x on the denominator. So I'm now going to times every term by x. So that first term becomes negative 40x squared. The second term, well, luckily the x's cancel out, which was the purpose of all that. So I'm going to add 20. And then the last term becomes negative 4x equals 0. Now I'm going to move everything to the right-hand side so my x squared terms becomes positive. And I get that. And then I would probably use quadratic formula to solve that. But if you like, before you do that, you could even divide everything by 4. So it becomes 10x squared plus x minus 5 equals 0. And then you get x equals negative b, which is negative 1, plus minus root b squared minus 4 times 10 times negative 5 all over 2a, which is 20. This becomes negative 1 plus or minus root. Okay, so that becomes 201 over 20. Now, if we go back a second and look at what x is a width. X has to be positive. Therefore, the only value of x that's relevant, because let's split this up, that means x could be -1 minus root 201 over 20. Now that's definitely going to be less than 0. You can check on your calculator. Or x equals -1 plus root 201 over 20. And that's going to be positive. So that has to be our answer. That's not a solution since x is bigger than 0. So this is your answer, and if you check that on your calculator, I got 0.65 approximately, and that's 0.65 meters, so approximately 65 centimeters. So that is the original width of the floorboards. So that's the width of the floorboards. Now this last one was definitely a tricky question. Okay, so don't feel bad if that was a little bit hard. Basically, the trick, first of all, the diagram was helpful. The first equation wasn't so bad because, the number of floorboards times the width must equal the length of the floor, which is 20. And then you just had to think of the new one, which was a little bit more challenging. So the new width, find an expression for that, and the new length. Now also you might be wondering, if this is supposed to be all on quadratic equations, why did I bring in two variables? Really, it should just be x. But I just found that the easiest way to tackle this particular question, by letting x be the width of the floorboard and y be the number of floorboards, and going from there. So sometimes you just got to do, just tackle a question any way you can think of. So, that was a little bit of a hard one, that last one. The other ones are pretty standard. So, this all now corresponds to exercise 1F, I believe. So make sure you do a few of those to make sure that the ideas have really solidified in your head. Okay, thank you, girls.